Okay, so for this part, we are going to be doing von Neumann stability analysis. And one thing that I realized that I did not correct in part 2, but I did include it in the code, is that with this equation, this R means that we can get rid of this and this, because these are already represented in the equation for R. So what we would end up with is the formula that I'm going to write down here. So for the von Neumann stability analysis, we're starting with the equation that we found in part 2, which is going to be Tj to the n plus 1 equals Tj to the n plus R times, and this is just going to be the top part of the numerator that we saw in the other one, because the delta x squared and the delta t is represented in this value of R. So we're going to have Tj plus 1 to the n minus 2 t to the j, or t of j to the n, plus Tj minus 1 to the n. And so what we found in the first video is that e to the I k, oh wow, okay, let's try rewriting that. E to the I k delta x times e to the negative kx alpha t is a solution for the heat diffusion equation, and so we can set this equal to Tj of n. And so what we're going to do is we are going to factor out this value, and we can use this definition in the future. So what we're going to do is we are going to have T of j to the n plus 1 is going to be equal to Tj to the n, and this is going to be factored out from everything. So from this area it will be 1 plus R, and then from inside these parentheses, if we factor it out of this term, then that will give us e to the I k delta x. If we factor it out of this term, it gives us a negative 2. And if we factor it out of this term, it gives us an e to the negative I k delta x. And so one of the identities that we know is that if we are adding this and this, that will give us cosine. And so we can rewrite this as Tjn 1 plus, and we're going to factor out this 2. We're going to have 2r, and this is going to be the cosine of k delta x minus 1. And so this is an identity that we have discussed that we should just know for this problem. And so what we want to do now is figure out what R can be to still be in the constraints of the problem. And so one thing you'll notice is that in this section, what is the highest, or I guess lowest, because it'll be a negative number, value that cosine can be? That is going to be negative 1. And so that is going to make this parenthesis be equal to negative 2. So we're going to write an inequality. It's going to be negative 1, and then we're going to have 1 plus 2r times negative 2, and then we're going to have 1. And so if we subtract 1 from both sides, we'll have negative 2 times 2r to the negative 2, 0. And then we're going to be, this times this is going to be negative 4, so we're going to divide by negative 4 on each side. This is going to just be 0 again. We don't really need to worry about this, but when we divide by a negative, it will flip this sign, so this is going to be this way, and this is going to be a positive 1/2, and this is going to be R. So for stability, R has to be less than 1/2.